Okay, so today our topic of discussion will be basis. Okay, first of all, I'm going to discuss the definition of basis. Okay. So, what do you mean by basis? Let's discuss the definition of it. So, a base is any metal oxide or metal hydroxide or metal hydroxide. Okay. First of all, this can be a definition. So a base is any metal oxide or metal hydroxide. Like for example, if we discuss about metal oxide, that would be sodium oxide, Na2O, or it could be calcium oxide. Okay. It could be, we can say, aluminium oxide. Okay. Or it could be copper oxide. Okay. So this is basically the definition of a base. And there is one more important definition of base, which is a base. Yeah, base is anything anything that reacts with acid that react with acid to form salt and water to form salt and water. Okay, like for example, if we have a base like sodium hydroxide is a base which reacts with HCl and they react to form NaCl, which is a salt and water. Okay, so you can see this is a base, this is an acid, and they both react to produce a salt and water. Okay, yes. Okay, so let's move further towards the difference that exists between a base and alkali. So what is actually the difference between a base and alkali? Okay. So first of all, I just want to discuss the difference between them. So we know that there are, first of all, group 1 metal oxides, and there are like most of group 2 metal oxides. Most of group 2 metal oxides. This term is very important. Metal oxides. Okay. They dissolves in water. They do dissolves in water and they form metal hydroxides. Metal hydroxide. Okay. And this metal hydroxide, they are basically alkali. They are basically alkali. So can we say this thing that the bases, like for example, group 1 metal oxide and group 2 metal oxide, they are base. They are base. Like for example, sodium oxide, okay, this belongs from group 1. And we have potassium oxide. This belongs from group 1 as well. like lithium oxide, group 1, and we have calcium oxide that belongs from group 2. Okay, this belongs from group 2. So they dissolves in water, okay, and they can form sodium hydroxide. Okay, so this is basically the example of an alkali. So can we say one thing that alkali is a soluble base? Okay, alkali is a soluble base. Like for example, it also dissolves in water and it forms potassium hydroxide, which is also a soluble base, and it is also said to be an alkali. Okay, and this also dissolves in water to form alkali, which is lithium hydroxide. It is also an alkali. And then group 2 metal oxide also dissolves in water, so it also forms calcium hydroxide. Okay, like you can see, these all alkalis, they are base as well. They are base as well. Okay, so you can see like this is also the alkali and also base as well. So these all, they are base as well. Only one thing that they are soluble in water, so they are called as alkalis. Okay. But on the other hand, there are some of metal oxide, like for example, copper oxide. Okay, this belongs from transition metal copper. So this metal oxide, you can say, and the some of the other metal oxide like lead oxide, so they are only bases. They are only bases, but not alkali. So we will not call them as alkali because they are not soluble in water. Okay. So boys, can we say one important thing here, that all bases are alkali, but all alkalis are not bases. All alkalis are not bases. Are not bases. Okay. Okay. So now it's quite clear for us to learn about this thing in detail, that all bases are uh, s- all alkalis are said to be bases, but all bases are not alkalis. Like for example, copper oxide is not soluble in water, lead oxide is not soluble in water. There is like one more important you can say example, which is magnesium oxide. Although it belongs from group 2, but it also does not dissolve in water. So we can say this dissolve in water. So we can say that it is only a base, but not an alkali. So I hope that difference between alkali and base is quite uh, you can say clearly understand to you. Okay, so let's move towards the next part, and that could be like, let's discuss about the properties of alkalis. Okay, so we can discuss about the properties of alkalis. Okay, they are quite important for us to understand. Okay, so let's start with it. First of all, alkalis have bitter taste and soapy feel. They have a soapy touch. Okay, and soapy touch. Like they are slippery to touch as well. The other property is that as we have learned that acid turn blue litmus red. So alkalis turn red litmus to blue. Okay, red litmus to blue color. And then we have these like, okay, what there's an important property of alkali, that alkali release release hydroxide ion when dissolved in water. When dissolved in water. In water. Like for example, we have calcium hydroxide, and when it is dissolved in water, so it would be releasing Ca plus 2 ion with the release of 2 hydroxide ion. Okay. So it's quite clear that when it is dissolved in water, the same like acids, that it would be releasing uh, calcium ion with the release of hydroxide ion. Okay. So after that, let's move towards another property, which is alkali reacts with alkali reacts with ammonium. Oh, first of all, like alkali reacts with acids to form salt and water. Okay. We know about like sodium hydroxide, when it reacts with HCl or HNO3, for example, the both are in aqueous form. This is also in aqueous form, and they would be forming salt, which is sodium nitrate, okay, in aqueous form, and this water, which is in liquid form. We have already discussed about aqueous form, that aqueous form is something which is dissolved in water, okay. So this is the example, but they also ask us to find the ionic equation for that. Very important question, which is oftenly asked in the exam, like find out the ionic equation for that. So in order to find the ionic equation for that, what we are going to do, we are going to split them into ions. Like only the aqueous form will be split up into its ions. How? Like sodium is Na positive. So first of all, this is broken, and there is OH ion, OH negative, plus nitric acid is also split up into hydrogen ion plus nitrate ion, NO3 negative, and they would be forming Na positive plus nitrate ion plus water. Okay. So sodium ion will be cut with this sodium ion, as they both are the same on left and right hand side, and they are also called as spectators ion because they don't take part in the reaction. Okay. And now nitrate ion, and nitrate ion is also same, so they would also be broken. So H positive ion plus OH negative ion, and they would form H2O. So this is the example of ionic equation. Ionic equation. Okay. Now let's move further towards another property which is also very important to understand, and that is, this property is also asked commonly in the exam, that when alkali reacts with ammonium salt, ammonium salt, they would be forming salt plus water plus ammonia gas, okay. Now alkali we have, like for example, is sodium hydroxide, ammonium salt, ammonium ion is NH4 positive. Okay. It can be ammonium chloride, which is NH4Cl. It can be NH4 hold twice SO4, which is ammonium sulfate. So we can use like any ammonium salt and the result would be the same. Okay, let's take ammonium chloride, NH4Cl. it would be forming, sodium is positively charged, chloride is negatively charged. So it would react with it and form sodium chloride with water and with the release of ammonia gas. Okay. So first of all, look at this, like, first of all, it's balanced or not. Uh, so we can say, yes, it's already balanced as well. Okay. Because there are same number of atoms on both sides. So this is aqueous form. Ammonium chloride is in solid form. This is also in aqueous form. This is in liquid form. So whenever alkali reacts with ammonium salt, they would be forming salt, water, and ammonia gas. Okay. So just remember one important detail here as well, that whenever neutralization reaction occur, you remember neutralization reaction is when acid reacts with base, they would be forming salt and water. So you can write this example if they ask you, like, what do you mean by neutralization reaction? So then how you're going to define it, that when an acid reacts with base, they would be forming salt and water. Okay. Uh, Another important question that is oftenly asked in the exam, and that is uh, this question, like, test for test for ammonia gas. Okay. There's one more important thing that I have not described up till now, which is uh, that ammonia is aqueous solution of ammonia, that is basically a weak alkali. That is a weak alkali. Okay. That is also a weak alkali. So it's aqueous solution. Ammonia's aqueous solution is a weak alkali. And the test for ammonia is that uh, ammonia gas, ammonia gas convert a wet red litmus paper into blue color. As it is a weak alkali, so it is converting wet red litmus paper into blue color. Okay. And the other thing that I just want to discuss, that it also has a pungent smell. Okay. That it also has a pungent smell. Okay. So I hope we have discussed with every details of alkalis. And there's an other property as well, in which let's discuss this property as well. Like, alkali reacts with salt to form metal hydroxide and an other salt. Okay. Like, for example, when sodium hydroxide reacts with iron sulfate, so you can see this sodium would go and react with this, and it would be forming sodium sulfate. Okay. It should come here, and here we can write at as Fe reacts with OH. We don't know the charge of Fe here. So we can see that Fe plus 2 combines with sulfate SO4 minus 2, and it is having FeSO4. Okay. So that means charge of Fe is plus 2. Okay. And with plus 2 charge, it reacts with hydroxide ion, and it would form OH negative, and the formula would become FeOH whole twice. Okay, formula would become FeOH OH whole twice. Okay. So this is another property when alkali reacts with this salt and they would be forming sodium sulfate and iron hydroxide. We need to balance it as well. There are two sodium here, two hydroxide here. So we are going to put two here as well. Okay. So let's move further towards some of the uses of base and alkali that is also asked in the exam as well. So let's discuss about them. So uses of alkali and base. Okay, so let's discuss about them as well. So first of all, we have ammonia solution, ammonia in aqueous form. What are their uses? First of all, they are used in cleaning, window cleaning solution. They are used in window cleaning solution. Okay, window cleaning solution. And the other one is that they are using in the manufacturing of fertilizer. Okay. Then we have calcium oxide that is basically used in neutralizing acidic soil. Acidic soil. Okay. And they are also used in making iron, concrete and cement. Okay. Then we have magnesium hydroxide that is used in toothpaste to neutralize the cavity or the bacteria or the acidity that is present in our teeth. Okay. And they are also used in toothpaste. They are also used in uh, antacid, used as an antacids to relieve indigestion. To relieve indigestion. Okay. So, like if there is acidity that is present in the stomach, we used to take these medicines, and magnesium hydroxides are present in those medicine. So they are basically used to relieve indigestion. Then we have sodium hydroxide, okay, that is used in making soap, okay, and this is also used in cleaning detergents, okay. So these are basically the application of it. Okay.